So last class, we did trig with any angle. Do you remember how I gave you a point and we figured out what quadrant it was in? And then we did Pythagorean theorem and got all the sides, opposite, adjacent, hypotenuse, all that. And it could be anywhere that we wanted. Today, we're going to do very, very specific angles. So they can't be anywhere. They have to be what's called the unit circle, okay? The reason it's called a unit circle is because the radius is 1 unit. R is going to be 1 for all of these, okay? And we only use our special right triangles. So do you remember these 45, 45, 90, and 30, 60, 90? Okay, in radians, this would be pi over 4, pi over 4, pi over 2. Instead of 45, 45, 90, it'd be pi over 4, pi over 4, pi over 2, as we now need to like start getting used to calling it, okay? And so I'm going to draw the triangle in quadrant 1 for each of these, just for the sake of drawing it somewhere. But then we're going to reflect the triangles into all the other quadrants as well. But what's cool is if you can understand quadrant 1, the others are all the same. You just keep reflecting it. It's the same thing over and over again. So R is 1 for all of these. The hypotenuse, that's going to be 1. And this is 45, 45, 90. It's not to scale. I didn't get out a protractor. It's just draw something with 3 sides, okay? Now, I'm betting no one remembers the pattern. That's totally okay. I'm going to bring it up, and I'm going to just do like a little side problem to work it out. To get from the hypotenuse to the smaller side for your 45, 45, 90, you divide by square root of, does anyone remember? So, oh, good. You divide by square root of 2. So you would take 1, divide it by square root of 2. But you have to rationalize that. So if you rationalize that, what would you get? Square root of 2 over 2. And both sides would be the same because it's 45, 45, 90. It's an isosceles triangle. So now let's do a 30, 60, 90. Again, I'm drawing it in quadrant 1, just for the sake of drawing it somewhere. Oh, and as we should get used to calling this is a pi over 6, pi over 3, pi over 2 triangle. That's what 30, 60, 90 is in radians. So I'm going to put the 30 down here and the 60 up here. Again, it's not drawn to scale. It's not perfectly drawn. I just threw the numbers in there. And the hypotenuse is 1. Again, that's the idea. For the unit circle, R is 1 the whole way around. It's a radius of 1 unit. To get from the hypotenuse to the smaller side, and that would be the one across from the 30, that's the smaller side, across from the 60 would be the bigger side. To get from the hypotenuse to the smaller side, you divide by 2. So 1 divided by 2 is a half. That's just what that would be. And then to get from the smaller side to the bigger side, you multiply by square root of 3. Oh, good. So if you do a half times square root of 3, it would be a half square root of 3, or square root of 3 over 2 is what we said. Now, 45, 45, 90, because those are the same, it would be the same the other way around. But 30, 60, 90, if we reverse that, it creates the opposite triangle. So if I put the 60 down here and the 30 up here, again, it's not to draw it because it's going to be on the unit circle. It's not to scale, obviously, but you kind of have to imagine it being the other way around. Hypotenuse would still be 1, but if I reverse the angles, then the sides are also like switch. It's going to be the other way around. So your 1/2 would be here and your square root of 3 over 2 would be here. Just remember, the small side goes across from the small angle. The big side goes across from the big angle. It should logically make sense. Okay. So you only have 3 options for your angles. Your world becomes very, very small. The small angle is 30. The medium angle is 45. The large angle is 60. In radians, this would be pi over 6. And here's how I help people try to remember which one's which. If you were only given a 1/6 of a slice of pie, wouldn't that be a small amount? Like if you only got a 1/6 of something, okay? 45 is pi over 4. Usually that goes okay because that's the one that's halfway in between, like it's a 1/4. And then 60 is pi over 3. If you get a third of a pi, well, I hope you wouldn't eat a third of a pie. That would be a lot of pie. Anyway, that's the larger one, okay? And then you just have to remember what goes across from them. Across from the smaller side, or the smaller angle, I'm sorry, across from the smaller angle, you get the smaller side, which is a half. Small goes across from small. Across from the medium one, you get the medium side, which is square root of 2 over 2. And then across from the larger one, you get the largest side, which is square root of 3 over 2. However you want to remember this is up to you. I remember it small, medium, large. Some people will remember it this way. Do you see how this goes 1, 2, 3? Some people will remember it that way. Some people will remember the ones with the 3's go across from each other, like the pi over 3 and the square root of 3 over 2 go across from each other. Up to you how you remember it. There's a lot of different ways, but that's what you got to remember how to do. All right, so go ahead and get out your unit circle. We're going to fill it in together, and I'm going to color code. You're welcome to do that as well. If not, that's fine too. But we're going to go do the quadrant angles first. That's the up, down, left, right. Now I'm going to have to zoom out so that you can see the whole thing. That means it's a little bit smaller. If you need me to repeat anything I've said, if you can't see it, just let me know, okay? This center point is 0, 0. That is the origin. So it's centered at 0, 0. And remember, the radius is what? 1. The radius is 1. It's called a unit circle. It's 1 unit. I'm going to go around and do all the quadrant angles first. That's like the north, south, east, west ones. If you are here, how many degrees have you rotated? Good. Okay. And then how much pi have you rotated? 0. No pi. What would that coordinate point be? Now, if this is 0, 0 and your radius is 1 unit, 1, 0. This is why I am so enthusiastic about encouraging everybody to say 0 pi when it's radians, so you don't get it mixed up with this 0. Do you get what I'm saying? Okay. Now we're going to go up to the top. How far did you rotate in degrees to get up here? Good. 90. What is it in radians? 1 pi over 2, a half a pi. And if this is the origin and the radius is 1 unit, what's that coordinate point? 0, 1. Now we're coming over here. What is this in degrees? It's 180. How much pi? Yeah, 1 pi, a pi. And if this is the origin and the radius is 1 unit, what's this coordinate? -1, 0. Good. And then lastly, down here, how many degrees? 270. Now it would be 1.5 pi, but you can't write 1.5 pi. That's not a thing. Yeah, it's 3/2 pi, 3 pi over 2. And again, this is the origin. You went down 1 unit, your coordinate 0, -1. Cool. That's what I always do in the first color. If you are color coding with me, set that color aside. Now we're going to do the ones in the middle. Okay. All you have to do is for the degrees, keep adding 45. And for the radians, keep counting by 1/4. So this one is 45 degrees. Let's go around and do all the degrees. This one's 45. If you come over here to, well, here, let's add 45 again, you would get 90. We already have that one filled in though. If you add 45 again, what are you going to get for this? 135. You're just adding 45. So if you add 45 again, you would get 180. That one's already filled in. If you add 45 again, so 180 plus 45, 225. Good. Those are good with that. If you add 45 again, you would get 270, which is right here. If you add 45 again, 40, yeah, we're adding 45 each time. So 315. And hey guys, if you add 45 again, guess what you get? 360. It would be the whole way around. Okay. Now let's go and do the radians. This would be 1/4. And again, I don't always say the pi, but put it in there. 1/4. Watch me point to this because it's as easy as counting. That's 1/4. This is 2/4. You see that? We just already have it filled in. What would this one be then? 1/4, 2/4, 3/4, 4/4 is 1 whole pi. So the next one is 5/4. 6/4 is 3/2, and so this one would be 7/4. And then 8/4 is 2 pi, which is the whole way around. Okay. Now we're going to do the coordinate points. Oh my gosh, over here in the notes, what did we say were the sides for the 45, 45, 90 triangle? What were these sides? I'm pointing at them. Hello. Square root of 2/2. Do you see how they're the same? Okay. So this is going to be square root of 2/2, comma, square root of 2/2. And if you envision the triangle in here, like try to imagine this triangle in here, you went to the left square root of 2/2 and then up square root of 2/2. Now connect that to this one that we did over here. The only difference is what? This point, if you bring it over here, which one's negative, the x or the y? X. So it's negative square root of 2/2, square root of 2/2. I told you it was repetitive. Now, if you bring that one down here, they're both negative. 2, comma, negative square root of 2/2. And then if you bring that over here into quadrant 4, positive and then negative. Good. Square root of 2/2 and then negative square root of 2/2. I hate that the colors don't show up very well on here. And then what a lot of people will do is connect them. Again, you don't have to do this. I'm just showing you what this would look like. I should have gotten a ruler, but oh well. Okay, do you see how they reflect? It's the same thing over and over and over again. If you are color coding, go ahead and get out your third color. I guess I only use 3 colors for this. I guess I use 4 sometimes. I'm debating if I should make all these the same color for the last one or I'll make them different. All right, now let's go do all the 6. All right. What would your first amount of degrees be here? Think back about the other special triangles we did. We did the 45s. This would be 30. I'm going to make these 2 different colors. It's not showing up well on here. When I take the picture, it'll show up on. Okay. Well, I'm going to make this one 30. I'm going to make this one, I'll be in a different color. But you're going to just keep adding 30. So 30 plus 30 would be 60. Add 30 again. 90. That one's already filled in. Add 30 again. 120. Add 30 again. 150. Add 30 again, that would be 180. And then 210. Add 30 again. 240. And then you'd have 270. And then 300. 330. And oh my gosh, if you add 30 again, you would get 360, which is the whole way around. Now, when you go and do it in radians, you're counting by 6. Then it always sounds like I'm listening when I do this, but you're just going to go 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. You following me here? You can count, you can do it. So this one's pi over 6. That's 1, 6. The next one would be 2, 6, but you have to reduce that. 2, 6 is 1. Good. Perfect. 2, 6 is a third. 3, 6 is a half. Good. And so you already have that one filled in. 3, 6. The next one would be 4, 6, which is 2. Good. 2 pi over 3. 4, 6. The next one would be 5, 6. And then 6, 6 is pi. So this would be 7, 6. And then 8, 6 would be 4 thirds. Good. 8, 6 would be 4 thirds. 9, 6 is the one you already have filled in. 10, 6 would be 5 thirds. And then 11, 6. And then, oh my gosh, guys, what is 12, 6? How many pi is 12, 6? 2 pi, whole way around. Cool? Okay. Now we're gonna go and fill these in. Ooh, back to the notes. What were the sides of the triangle for these ones? 1/2 and square root of 3/2. Okay, let's do this one. I want you to envision the triangle in here. Can you see it? Envision it here. Do you see how you went further for x than you did for y? Like the x distance is further than the y distance. So this is going to be the square root of 3/2, comma 1/2. The x is more than the y. Like the x is the one that's bigger. Now just watch me point to it because it's very repetitive. I'm going to take this point and match it up with this point. Do you see how it's right across from it? If I take this point and bring it over here, what's the only difference? Negative on which one? X, good. It'll be negative square root of 3/2, comma 1/2. Bring it down here. They're both negative. Negative square root of 3/2, comma negative 1/2. Bring it over here. What is going to happen? Good. Y is negative. So it'll be square root of 3/2, comma negative 1/2. And if you want to connect those, you can. Some people like to do this. It looks kind of trippy when you're all done. But do you see how I can connect these? Now, when you go and do the last ones, again, try to envision this triangle in here. Do you see what I'm like trying to show you? Do you see how you went not as far in the x direction as you did for y? Like y is the bigger one. Okay, you're going to take this point and do what with it? Flip it. It's 1/2 square root of 3/2. Now, when you connect to this point, it'll be negative 1/2 square root of 3/2. And then down here, they're both negative. And then over here, only the y is negative. And if you want to connect them, you can. All right, kiddos. At any point, did I tell you to memorize this? I told you to count 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Do you memorize how to count? No, you just know how to count. And once you do the first quadrant, you just take it and flip it over here and then flip it down here and then flip it down here. Yes, you have to know this, but do you understand that knowing is different from memorizing? I don't want you to memorize this. I want you to know it. At no point did I tell you to memorize it. I showed you where it all came from, and it just comes from counting and reflecting what you have into the other quadrants. Okay? So what we're going to use the unit circle to do is answer our trig functions. This is exactly what we did last time, except instead of being like anywhere, it has to specifically be at one of these. So again, your world becomes very, very small. So your trig functions are your sine, cosine, tangent. Go ahead and draw another triangle. I know you're like another triangle. Yep. What's the hypotenuse gonna be? 1. It greatly simplifies your life when that's 1. And as a heads up, and especially to any of my people that took Algebra 3 trig last year, I make you draw a triangle and label it for every problem. And you're allowed to feel however you want to feel about that. And if angry is how you feel, that's fine. That's valid. I'm still going to mark it wrong if you don't draw and label a triangle. It's 3 sides. Work with me. Okay? Because there's so few answer possibilities that you could just guess the answer. So I want to see you trying. All right. This is your angle. This is X. This is Y. SOHCAHTOA has not gone away. It is still the same thing, right? Sine is what over what? So look, opposite is y, hypotenuse, take 2. Hypotenuse is 1. Y over 1 is just y. Y over 1 is just y. How would you get cosecant? Yeah, you would flip that. Now, can I have a really brief conversation about that? Don't put 1 over whatever it is, just flip it. Okay? Just flip what you have. Just flip it. All right, cosine would be adjacent over hypotenuse. That would be x over 1, which is just x. Secant means you would flip that. Don't write 1, because people will write this. They'll write 1 over square root of 3/2 and then become completely confused. Don't do that. Just flip square root of 3/2. Like, just flip it. That's all that means. Don't do this. Okay, that ends up just confusing everybody. All right, tangent would be what over what? Opposite over adjacent, so that would be y over x, and so cotangent would be x over y. If you don't want to write this down, that's fine. If you're a steps person and you're like, Ms. Cole, I need some steps, here are the steps for how you get through these. Number one, decide what quadrant you're in. How many quadrants are there? You got a 1 in 4 chance of guessing. Number two, decide your angle. It's either 30, 45, or 60. You got a 1 in 3 chance of guessing. Okay. Then do the sides. It's 1/2 square root of 2 over 2 and square root of 3 over 2. So again, you only have 3 options. And then number 4, you're going to answer the question. And that's based on whether it's sine, cosine, tangent, or one of the other ones. Sine is y, cosine's x, blah, blah, blah. Okay, so you use that to answer the question. So for this first one, it doesn't matter that it says sine. That doesn't matter until we get to step 4. The fact that it says sine doesn't matter. It's just the 210 degrees, okay? What quadrant is 210 in? 3. Draw a triangle in quadrant 3. Good, we did step 1. Nice job. Now, you want your reference angle. Reference angle, that's this angle right in here. If the flat line is 180 and we went to 210, what's this reference angle? And it's 30, 45, or 60. You only have 3 options. It will be 30 there. That's step 2. Now the sides. What goes across from 30? Across from 30 is a half. The side across from 30 is a half. That means that the other side is square root of 3 over 2. Okay. Now, if you're not in quadrant 1, and I guess I didn't put this in the steps there. If you're in quadrant 1, everything's positive. If you're not in quadrant 1, you need to figure out what's negative. We're in quadrant 3. So what's negative? Yeah, like both of them are negative. So I guess you have to decide your negatives. I should have probably put that in there as a step. When you do your sides, decide if there are negatives. There might be and there might not be. If you're in quadrant 1, everything's positive. All right, that is the work. That is the amount of work I need to see. Is a labeled triangle. Are we together? That's the quote unquote work. Now the answer depends on what it says here. This one says sine. Sine is the y value. Which one of these is the y value? Negative a half is your answer. But here's the thing. I need to see this because there are so few answer choices. I need to know you didn't just guess it. So I need to know you can draw a triangle. Let's try it again. Step 1, quadrant. You're rotating backwards for this one. So it's negative 300. What's the whole way around? It's in quadrant 1 because look, the whole way around's 360. You almost went backwards the entire way. So your triangle's in quadrant 1. Step 1, good. Step 2, what's the reference angle? Well, good. Why is it 60? 360 is the whole way around, but we went 300. Step 3, what goes across from 60? Good. Square root of 3 over 2. What does that mean this side is? 1/2. That is the work that I want to see. That's the quote unquote work. Now you answer the question, and that's based on the fact that this says cosine. Cosine is x. Which one of these is x? 1/2 is your answer. Oh, why weren't there any negatives? We were in the first quadrant. Okay. Yeah. Question. Hold on. Let me keep us all together. Say it again. X is going to be left to right. Y is going to be up and down. No, valid question. And someone else is probably thinking the same thing. So I'm glad you asked it and I can clarify. X is left to right. Y is up and down. All right. Where is 5, 6? What quadrant is 5, 6 then? 2. 6, 6. Hold on. 6, 6 would be a whole pi. If you only went 5, 6, you didn't quite make it. Now look, when you're in radians, the reference angle is super easy. Because it's either a sixth, a fourth, or a third, and the denominator has to match. So do you see how this denominator is 6? It's pi over 6. If the denominator was 4, it'd be pi over 4. If it was 3, it'd be pi over 3. That's like, radians are pretty easy. All right, now what goes across from a 6? 1/2. Remember, it's the little one across from the little one. What does that mean the other side is? Square root of 3 over 2. Oh, but it is negative. Why is it negative? Quadrant 2, you went to the left. Okay, that is the amount of work I need to see. Work with me on that. That's not like, I'm asking you to draw and label a triangle. Now, tangent is what tells you like how to get your answer. I wrote it up here so you didn't have to keep flipping the paper over. Tangent is y over x. That's going to be 1/2 over negative square root of 3 over 2. Now, before you freak out, I know, because I know that looks awful. Do you see how these both have 2's? They cancel. Hey, Miss Cole, will that happen every time? Yep. So you have negative 1 over square root of 3, and then that's going to rationalize negative square root of 3 over 3. Just like that. Negative pi over 4. What quadrant is that going to be in? You went backwards a fourth. 4. Good. You went backwards a fourth. So your reference angle is pi over 4. A reference angle can't be negative. Again, cannot be negative. What goes across from a fourth? It is square root of 2 over 2. That means the other side is also square root of 2 over 2. Now you're not in quadrant 1, so something's going to be negative. Is it the x value or the y value? Your y value is negative because you went down. So this is your work. That's the amount of work I need to see. Now cosecant tells you how to get your answer. Don't write 1 over a crazy fraction. It just means that you're going to flip it. Now we're flipping the y value, which is this one. So if I flip that, it will be negative 2 over square root of 2, and we're going to have to rationalize that. So that would be negative what? 2 square root of 2 over 2, negative square root of 2. Now, I know that there's a ton of things to memorize, but what I usually tell everybody is, if you flip square root of 2 over 2, you just get square root of 2, and you might want to just know that one because it gets crazy with the 2's, but anyway, that's how that works. All right, where is 7, 6? Which quadrant is 7, 6 in? Good. And do you see how through practice you're going to get better at this? This is very much a drill and practice thing. And as a heads up for next class, we're going to do your quiz, and then we're going to do nothing but practice this. I have Quizlet game we're going to play, and it's like, it is literally a drill and practice thing, right? What's your reference angle? Pi over 6, 1/6. 1/6 is the little angle. What goes across from it? 1/2. That means the other side is square root of 3 over 2. What's negative? Because we're not in quadrant 1. Why are both of them negative? In the third quadrant. Good. Okay, that's your work. Now you answer the question. It says secant. Secant means we're going to flip the x value. This is your x value. So we're just going to flip it over. Don't write 1 over negative square root of 3 over 2. That ends up confusing everybody. Just flip it. And then when you rationalize that, it'll be negative 2 square root of 3 over 3. What quadrant is negative pi over 6 in? 4. Good. You went backwards a 6. So your reference angle is pi over 6. A 1/6 is a tiny little slice. If someone gave you a 1/6 of something, you'd be like, hey, that's not very much. What goes across from that? Good. The small side. That means the other one, square root of 3 over 2. Now something is negative because we're not in quadrant 1. The y value, the 1/2. Good. That is the work. Cotangent is how you answer the question. Cotangent is x over y. So that's going to be square root of 3 over 2 over -1/2. But what happens? 2's cancel. You have square root of 3 over -1, which would just be negative square root of 3. I'm going to skip 7 and 8 just for the sake of time here because it's just more of the same. What 9, 10, 11, and 12 are your quadrant angles. On the unit circle, where did I set my unit circle at? These ones on here, mine are pink, but do you see like the north, south, east, and west ones? Like those? Okay. When that happens, you don't get a triangle. You just draw the unit circle. Using words like up, down, left, or right, where is 3 pi over 2? Down, and it is the point 0, -1. So when you get one of these quadrant angles, that's the amount of work I want to see. Like that's the quote unquote work. Okay. Now sine is how you answer the question. Sine is the y value. Which number in this point is the y value? -1 is your answer. So when you get a quadrant angle, one of the up, down, left, right ones, that's how you do it. Just draw a circle. Using a word like up, down, left, or right, where's pi? Left. What is that coordinate point? -1, 0. That's the work that you need to see. And then tangent is how you answer the question. Tangent is y over x. That would be 0 over -1, but 0 divided by anything is just 0. You can't divide by 0 though. So if you get a 0 denominator, that's undefined. Okay. I wish that there was a pi with this. I'm going to go ahead and put a pi there. Where is 0 pi? No pi. On the right, and that is 1, 0. Good. That's the work. Cotangent's how you answer the question. Cotangent is x over y. That would be 1 over 0, which is undefined. You can't divide by 0. As foreshadowing, because we're eventually going to graph these, what does that mean would be in the graph? If it's undefined there. Vertical asymptote. Good. Perfect. All right. And then where's pi over 2? Up, down, left, right. Up. What's the point? 0, 1. That's the work. Cosecant is how you answer the question. Cosecant means you're going to flip x or y. Means you're going to flip y. Now, y is 1. If you flip 1, I mean, like, that would be 1 over 1, which is 1. So just 1 for that.